And the final step is to check your central atom right here. Make sure that if there aren't enough electrons, you can use a lone pair from one of the atoms on the outside, and it's actually the least electronegative atom, and it makes a double bond. And you're going to continue moving electrons until this central atom has 8. So we're going to check this. Note, though, that there are 2 central atoms that do not need to have 8, and that's beryllium, which has 4, and boron, which has 6. But everything else should have 8 on that central atom. This one's a little bit odd to draw. I'll go ahead and draw this one in. So to give the right number, if we do this like this, that will give us 2, 4, 6, 8, 10, 12, 14 electrons. If you had tried to do it this way, that also would have given you 2, 4, 6, 8, 10, 12, 14 electrons. I'm going to put it in there as a really tiny picture. There's something later on, and it's called formal charge, and it helps you figure out which of the structures is the right structure. But I'm going to go ahead and let you know on this one, it's this version. But you'll be able to know how to tell when it comes about. There's a few other cases you'll see come up where that also could be, there could be some variability. So in this case, all the atoms on the outside. And we need to make sure that that central atom has the right number. So in this case, nitrogen, it does have a total of 2, 4, 6, 8 electrons around it. So nitrogen is good. Don't forget a bracket if it's charged. So for the oxygen, here's one of the first cases that we might end up dealing with something. So as we fill this around, so right now we have 2, 4, 6, 8, 10, 12, 14. So when I do this, I get 14. But look, I only have 12 to work with. Before I had a bigger number in this column, but now I've got a smaller number. So that means that I can't have this. I only have 12 electrons to work with. So that's all I have to work with. So the way we fix this is that we grab a pair of electrons, and it'd be the least electronegative, but in this case they're the same. But you grab these electrons, if it'll let me grab them, and then you are supposed to be able to pull them over here to the bond. It's not cooperating with me. You want to imagine that it's letting me move these over towards the bond. I'll try a different pair. I guess it just didn't want that one pair to go. There we go. And remember, we don't draw bonds with dots. We use lines. Now, when we count that up, we have 2, 4, 6, 8, 10, 12, which is the number we're supposed to have. So we're going to put all of the atoms around the outside here. So when we add that up, you're going to have that there are 24 electrons. All right, so that's good, but look at the central atom. What's the matter with the central atom? He only has 2, 4, 6. So we have the right number of electrons. We can't do anything about the number of the electrons. But what we can do is we can pick one of these oxygens and we can pull them over and give them to him. Or there's a problem because now our oxygen doesn't have enough electrons, right? So, or what we could do instead of that is we could take those electrons and we could just use them for the bond. Now, if we do it that way, look, the nitrogen now has 8 electrons and the oxygen now has 8 electrons. So everyone is happy. Let's look at the next one. And by the way, if you had written one with a double bond down or a double bond to the side, that's totally fine. There is something to that, and it's coming up. So I'm going to go ahead actually and let you go ahead and draw CO2 and O3. There's going to be some kind of bonds going on with that one.